Hey everyone, Suhail this side. Welcome back to my channel and Kafka series. In the previous video, we built a Kafka consumer in pure Java and understood how message consumption works. In this video, we will complete the picture by implementing the Kafka producer in Java. We will cover the Spring Boot version in later videos, but this video is focused on helping you truly understand Kafka internals. We have already discussed acknowledgements and offsets in the previous video. But in this one, we will answer some important follow-up questions like what happens when an acknowledgement is skipped, or what if a consumer processes a message but acknowledges a later one. After that, we will see how a single consumer group can consume from multiple topics. And finally, we will implement a Kafka producer in Java and connect everything end to end. Without wasting time, let's get started. Hey guys, let's consider the scenario. We have the Kafka broker, we have the Kafka consumer, and we have a topic. And we have millions of messages. Let's assume so. Kafka consumer asks broker to deliver some messages. Of course, it will not be giving all million messages. It will be delivering the messages in batches. So broker gives, let's say, first 4 messages just to keep things simple, right? So it gives 4 messages to the consumer. The consumer processed 1 but did not acknowledge 1. Processed 2 but did not acknowledge 2. Processed 3 but did not acknowledge 3. Processed 4 and acknowledge only 4. Now the server stops for some reason. Okay, so the server starts again and it asks Kafka broker to deliver the messages. Now what all messages you think that Kafka broker will deliver? Is it 1, 2, 3, 5, 6, 7, 8 and so on? Actually no. Kafka broker will be delivering the messages from 5, 6, 7 and so on. It's mainly because the acknowledgement is something like a bookmark for Kafka broker to track where the consumer is. So when the consumer says it is acknowledging 4, that kind of implicitly means that the consumer has already seen 1, 2, 3 and it is good with all those things. So what was the last message it acknowledged? 4. So it will be giving the next messages from 5, 6, 7 and so on. Now let me show you the code as well, how we have done in the last video, how the consumer was committing the offsets, right? So let me open my IntelliJ, right? So if you see over here, this is the consumer which we have written, right, last time. So what I'll do is I will just create one new folder like day02 package is day02 so that you get to know what all things we have changed. So what I'll do is I'll just copy this, right, and paste it here, right? And this what I'll do is I'll just name this to day02 Kafka consumer. Now in the last video we have seen how the consumer was committing the offsets. It was committing the offsets via this. With this statement, the consumer is basically acknowledging the message to the broker that okay, I have processed this many messages. But in this method we are not passing anything, we are not passing any message, right? So what it does acknowledge? So it simply means acknowledge the last message. For example, in the diagram we have seen, right? So let's assume these are the records we received. The message 1, 2, 3, 4, right? So with this thing, what it would acknowledge? It would acknowledge just the 4, the last message, right? But in the last video, we did not see how we can acknowledge the individual message, right? So let's see the code changes, how we can acknowledge the messages individually one by one. So for that, what I will do is I'll just, for simplicity, I'll just traverse on these records, right? So if you know, once the consumer gets the records, it gets the record from the partition, right? And offsets are also maintained per partition, right? So that means the offset or the acknowledgement has to be done per partition. This record, what it gives me, it has everything. It has the key, it has the partition, it has topic, it has metadata information, it has everything. So to commit or to acknowledge the individual message, what I need to do is, firstly I need to create the topic partition. So let's create that, right? So this topic partition provides a constructor which accepts the topic and the partition, right? So we can do that, right? So this record has the topic information, has the partition information. Now we have the topic partition, right? Now what we need the offset. What should be the next offset, right? So for that, what we need to do is we need to do offset metadata. This offset metadata is also per topic partition, right? We have already seen in my last videos, right? So we have the topic partition, and for every partition we have the offsets information, right? So similar thing is this. So we have the offset and the metadata. So what we can do is we can just create the offset metadata, and here what we need to pass. So this record has the offset. We just need to increment it by 1, because as I earlier mentioned, offset is nothing, or it is just a kind of array which is being maintained internally inside the Kafka. So we just need to move the offset by 1, right? So that is what we will do over here, right? So now we have the topic partition, we have the offset, right? What is the next offset should be? So now we can just do this, let's say the consumer dot commit sync, and we just need to provide the map. Now why this is map? And map, if you see, the topic partition is the key and the offset information is the metadata, right? So if you have to do, if let's say if your topic has 3 partitions, in that case you can just provide this map so that you can commit in one network call multiple topic partitions. So that is why it is giving the map, right? So map has the key as the topic partition and the value as the offset metadata, right? So if you see this, it would commit the single message individually, right? So that's how we can acknowledge the message individually. I will just add the logging here itself, right? So let's say I will just do the log.info, right? So I'll just remove this code, and that's how your code would look like if you want to commit or acknowledge the message individually. Now let's move further. What if the acknowledgement is skipped? Let's say we have developed some consumer application. This application is about processing credit card events. Let's assume so, right? So this application would ask Kafka broker to deliver some messages. So it got some messages, it has processed all of them, it has charged their end users. Now when we were about to send some acknowledgement, some network issue, so it did not make it to the Kafka broker, or when we were about to send acknowledgement, someone restarted the server. So what would happen in this case? After restart, if I ask Kafka broker to deliver some messages to process, will Kafka redeliver the same messages, whatever I have processed earlier? Actually, yes. Kafka will redeliver the messages whatever we have processed earlier, because we have not sent the acknowledgement. Okay, in that case, will I not be processing one more time? Will I not be charging my end users one more time? Actually, yes, that could happen. Okay, how can we fix this? To fix this, we have to make our producer to set up some kind of unique message or event ID, something like UUID. Remember, I'm not talking about keys are different. I'm talking about very specific unique ID to specify one particular event. So some kind of unique ID for each and every event. This ID could be part of payload or could be part of header. It's all up to us. So producer writes the message to the broker, consumer asks for messages, Kafka broker gives the message, but don't process immediately. We have to check our database. Have we seen these messages already? If they are present, they are duplicates, don't touch them. Simply acknowledge. Acknowledge without processing. If these IDs are not present, then these are like new messages. We can process, and after processing, what we need to do, we need to insert this message ID into this database first and then only acknowledge. This is how we have to make our application idempotent consumer. So this consumer has to be idempotent. Remember that this is the application. We as a developer has developed this application. So it is our responsibility to keep this application safe. It is not producer problem. It is not Kafka broker problem. It is something which has to be done by the consumer. Now, the next question could be, what if the producer does not have the message ID? What should I do? In that case, what consumer can do is, consumer has everything, right? For example, we have seen the code, right? The consumer, whenever it is consuming the message, it has everything. It has the key, it has the value, it has the topic, it has the partition, it has the offset, it has each and every information, every metadata. So what consumer can do is, consumer can create a message ID with the combination of all these metadata information and can store the message ID in this database, and can check whether this message is already present in this database or not, right? And accordingly it can process the message, right? So that's what we can do in this case. There is no specific consumer idempotency property at the Kafka broker level. There is nothing like that. So it is our responsibility to make these changes in the consumer application. Now let's see how we can consume from multiple topics. Okay, first question, why would someone want to consume from multiple topics? Let's imagine this is an inventory service, right? And this application wants to deduct from the inventory as and when order event happens, order is placed. So similarly, some people might be returning the orders, might be they do not like the product, right? So it could be like the application level, for scalability or for some other reasons, there could be different topic for the order returns, right? But the processing by the inventory service is the same, right? It has to ideally deduct the inventory, or it has to just increase the inventory, right? So the processing of this consumer is same, but just for scalability we have done this segregated into two topics. It could be like that, right? So in this case it could be possible that this consumer has to listen or has to retrieve the messages from multiple topics. Let's see how we can do that in Java program. So what we can do is, so for example, in this I have given the play group 1 to 3. Let's say the consumer group is inventory group or inventory service, right? And we have each and everything here, but instead of here we are providing the consumer.subscribe, it accepts the list. What we can do is, if you see, it can accept the pattern as well. So we can provide the pattern. So for example, I can provide the pattern dot compile, right? And I can provide the orders. Let's say the order dot star. Let's say this is my pattern, right? So now it would start getting the messages from multiple topics. So what I can do is, instead of logging the key value, I can just log the topic as well, and so that you can see from which topic it has got the message, record.topic, right? So we are good. Now what I need to do is, I need to just see whether my topic is there or not. So I'll just go to the console, right? So let me go to the console, and let me see whether my Kafka container is up and running or not. So my container is running. I need to go into this Kafka container. So the guys who are new, so please refer to the Docker Kafka setup on day 3 of my Kafka series. You will get to know how we can set up the complete Kafka on our local machine, right? So I can just go cd Kafka bin, right? So what I can do is, I can just see Kafka topics.sh bootstrap server, and I need to provide the local host 9092. Then I need to provide the list, right? So there is nothing has been created, right? So what I can do is, I can just quickly create like topic, I can just do order events, and I can just do partitions as one, and I can do the create. Let's say this is one topic, and if I do the list, I got the order events. And similar to this, I can just create one more topic as the order returns, right? Order returns, right? Now my two topics should be there, right? So my two topics are there. Let me resize this so I can show you. So for this, what I'll do is I'll open a different terminal so that I can just show you parallel the console logs as well as sending the message as well. So I'll just close this, and I'll just open the different terminal. Let me open that. So with this terminal, you can clearly see the messages on both the terminals, and also you can see the logs as well, right? So you can do you can see all the messages. So what I'll do is I'll just go to the Kafka container quickly, right? So Kafka container, I just go. So similar to this, I just need to go again on this as well, right? So I'll go to cd Kafka bin, and here I'll just do Kafka console producer, and I'll just do bootstrap server localhost 9092. Then I just need to provide the topic, let's say the order events, right? And similarly on this as well, I just do the cd Kafka bin, right? And again, I just need to start the producer here. Just the topic name is different. I'll just use the order returns, right? Now if I do order one, right, let me start the consumer as well. So I'll just start this consumer day 021, right? So let me start this consumer and see, right? Now my consumer is started, right? Now I just start sending the message, let's say the order one, right? So if you see in the logs, you would see the order one, right? Similarly, if you send the order two, right, you can see the order two as well. Order three, you can see the order three as well. Now let's start sending me the return message, order one return, right? So if you see, the order return has also been received, and since we have already done the logging for topic, key and value, so everything is being displayed over here. So the first three messages are from topic order events, and the last message, the order return, is from the topic order returns. Let me send one more message from this topic and see. So if you see, it is getting all the messages, right? So that's how you can basically consume from multiple topics. Now let's see how we can do the producer, how we can create the producer in our Java program, right? Let's do that part. Instead of producing the messages from the console producer, we will use that producer to produce the messages. Let's do that part, how we can do that. So if you see, similar to Kafka consumer, we do have the producer, right? And producer also needs some kind of configuration. What configuration it needs? Anything. It needs the bootstrap server, as we have already seen, right? The bootstrap server, right? The producer needs the bootstrap server, and then since we are doing this in Java program, now it needs the key serializer and the value serializer. Similar to what at the consumer level, what we need at the consumer level, we need the deserializer, because it needs to read the data from the broker, what kind of data it is. But at the producer level, we just need serializer, not the deserializer. So I'll create the producer in day 2 package, right? And let me give the name as similar to this, day 02 Kafka producer. Let's say this is my class, right? And let me create the main method over here as well, right? So I have created the main method. Similar to Java consumer, what we have over here, we have the properties, we have the bootstrap server. So what we need to do over here, we need to just provide the same thing, the bootstrap server we have provided. Now the other thing what we need is we need the key serializer, because group ID is not something which we need at the producer level. It is the consumer related configuration, as we discussed in the last video. So we have different configurations at different levels. So every component has the different configuration. So similar to this consumer config, we do have the producer config. So instead of consumer config, we need to use the producer config, because producer config has different set of properties, right? So we need to provide the key serializer, right? And in this as well, what I need to provide is string serializer. Let's say as of now we just need to provide the string serializer, and what which package it is having, the org Kafka Apache Kafka, right? So similar to key, we need to provide the value serializer, right? So I just do that value serializer, and now my producer properties are done, right? Now I just need to create the Kafka producer. Similar to Kafka consumer, as we discussed, right? We do have the Kafka producer as well, right? And it also kind of what kind of key it would be generating, producing, and what kind of message it is producing. So as of now, we are just saying that it would produce the string key and string message. Let's say the producer, and similar to this, we need to provide the properties in this constructor, Kafka producer constructor, right? So why it is saying like this, the exception or the error, because it is kind of implements the auto closable, right? So if you see, the closable is there. So if we are not closing the producer, so it would give this kind of warning that you are not closing the producer. So it is a kind of resource leakage. So what we can do is we can just do try with resources block we can use. Now we are good, right? Now what I need to do is we need to send the message. Let's say we need to produce the message, right? So let's say we are producing from I is equal to 0 less than 100, right? Let's say this is my loop, and what I'll do is similar to order 1, order 2, I'll just create key. Let's say the key is the integer dot toString I, right? So this is the key, and what is the value? The value is kind of, let's say, the order, right? The order, and let's say the I. So this is the partition key, and this is the value. Now this is the value which we were sending from the console producer. If you see over here, the order 1, order 2, order 3. Now similar thing we need to provide via this Java program. How we can do that? So for this, what Kafka library does is it provides few classes through which we can send the messages to the broker. So what those classes are? So to send the particular record or message, we need to create a producer record. So for that, there is a class like producer record, right? So if you see, this is the class, it depicts the single record, single message, right? So producer record, we are just creating the producer record, and if you see, we just need to provide the topics here, right? The topic is, which one is the topic? The order event is, let's say, the topic. And if you see the constructor for this, it has the topic, it has the key, it has the value. Now what is this key? This key is the actually partition key, right? We have also discussed so many times in last videos, right? So we know we got the producer record, we just need to send it now. How we can do that? So for this, producer provides this send method. We can send the record into this Kafka broker. So this is one mechanism to send the record. The other mechanism is it provides some kind of callback. So if you see the metadata and the exception, what kind of metadata? Let's say the broker did not process the message, or there might be some exception while sending the message to the broker. So we get each and everything in this. So we have the record metadata, we have the exception. These are the two things which we got. If the exception is not null, that means this message has some exception. It did not went through to the Kafka broker. So what we can do in that case is we can just log the message. So in this, similar to Kafka produce consumer, we can just have the logging applicable here. I'm just doing the copy paste operation for the logging. I just need to do the Kafka producer over here, right? So my job is done. I just need to log the message. log.error, and here I can just provide the exception, what kind of exception it is, right? Now what I need to do is, if the exception is not there, if the message has been processed, right, so I can just do that the produced message, or let's say the correlation ID, right? So I can just print out the key here, right? So this is the kind of key which we have printed, right? And here we are printing the exception, right? And we are iterating our 100, and let's give some sleep just to understand and see the things visually, right? So that's the reason I am just introducing the sleep. Otherwise there is no need to introduce sleep. Just I am introducing so that I can just show you how the messages are being processed, right? That is the reason. So right, duration of millis, let's say 100, and 2 millis. I can just do throws interrupted exception. Now it would be all right. At the end of this for loop, what I can do is I can just do the producer.flush, right? So what it does is it ensure all the sends are completed before closing. So because we have introduced producer in this try catch block, right? So what flush does is flush ensures the producer should not be closed unless all the messages are being published, because this, remember, this is the kind of asynchronous call, right? So behind the scenes it is sending the messages in batches, right? So it could be possible that if as and when we are just going out of this try block, the producer would be closed automatically, but there are some messages which are there at the producer level, right? So that is the reason I'm just doing the producer.flush, so that it will wait until all the messages are being produced, and after then only it would come out of this try block, right? Now we have the consumer already running, right? The earlier consumer we have already running. Now what I'll do is I will just start this producer as well. Let's start this producer as well, right? And see how things are working. So it is started producing the message. Now if you see the consumer logs, it is started consuming the messages, and if you see, it is consuming the messages from the order events topic, right? So it has processed the messages from 0 to 99, and it has produced the messages from 0 to 99. And if you see, after 100 messages are being processed, it has closed the producer, right? So similar to thing what we have done over here, right? We are just closing the producer. So similar thing we can do at the consumer level as well, right? So what we can do is we can just, instead of this try catch, right, instead of this try catch, we can do this similar thing over here, the try, and we can do this, right? So we can do this as well, right? And I can just move everything over here, and I can just move this while complete while loop and this, right? And the try is there. Now I don't need to write this. So it is kind of, the while loop is now inside the try block. Now even if you start the producer consumer again, let's start it again one more time, right? Now my consumer is started, right? Let's start the producer again, right? Producer, let's start the producer again and see how things are happening. Again it started producing the message, and the consumer, it started consuming the messages, it started processing the messages. So it has processed all the messages till 0 to 99, right? So that's all I had planned to cover in this video. Today we went deeper into Kafka acknowledgements and offsets, discussed acknowledgement skip scenarios, consumed from multiple topics, and implemented a Kafka producer in Java. In the upcoming videos, we will move on to a Kafka cluster concepts, do some code refactoring, and then build the same producer consumer setup using Spring Boot. If this video helped you, please do like it and share it with your teammates or friends. It really helps the channel. I'll see you in the next video. Thanks a lot.